So, hello engineers, today we are going to discuss a very important test as far as the geotechnical engineering is considered. And the name of the test is Standard Proctor's test. Standard Proctor's test. We call this test SPT test in short. So, what makes this test very important is that it establishes a relation between the water content of the soil and the maximum gamma D, which is the maximum dry density, which can be achieved when that moisture content is utilized. So, suppose we are having a soil sample of the site. We usually take the soil of which is undisturbed soil sample, and then we consider taking this test for various water contents and establish a relation between the water content and the gamma D. So basically this test considers taking a mold which is in the shape of a cylinder, and generally the volume of the cylinder is 1000 centimeter cube, and a hammer, and the weight of the hammer is generally taken as 2.5 kgs. So the volume of 1000 centimeter cube and a hammer of 2.5 kgs is what is the apparatus which is used for the continuation of this test. So this mold which we talk about has a diameter of 4 inches, which is listed over here, and the height of the mold, which is the cylinder, is divided into two parts. The top part, which is this, is called the collar of the mold, below which the actual height of the mold, which we generally take for the test, and this portion is of the height 4.58 inches. So in the standard Proctor test, suppose this is the actual cylinder, we divide it into three parts. Each part has a height of h by 3. We take the soil sample, which is the undisturbed soil sample, and we put the first layer, and then we do hammering of 25 blows each. We do the hammering of 25 blows, and after the compaction of the after the compaction of the first layer, we take the same process for the second layer, and then we continue for the third layer also. And when we have done the process, we remove the collar and we take out the soil sample, and we calculate its weight of the soil. So generally the weight of the soil, how do we do that? We take the weight of the mold plus soil, and initially what we have taken as the weight of the empty mold, we subtract both of them to get the weight of the actual soil sample, and then we divide it by the volume of the mold, which is generally what I have told you is 1000 centimeter cube, and then it comes out to be the density of the soil sample. And then we have a very basic formula which we use in the soil mechanics, is the formula of the gamma D, which is the dry density. The dry density is generally equal to the density of the soil divided by 1 plus water content. So by using this formula, the gamma D is calculated. So what we generally do is, what we generally do is we draw a table. The table consists of two variables. First is of the gamma D, and the second is of the water content. For various water content, we have the different values of gamma D. Suppose I'm taking just a generalized value. Suppose the water content is 2%, and we have some value, suppose X. Then we have 3%, and we have the value Y. And then we have Z% of water, and then we have the value of gamma D as this has to be removed. For the water content of 4, suppose we have the gamma D value of Z. So what we do is we draw a curve. We draw a curve. The curve, yeah, the curve on the x-axis has the water content, and on the y-axis we have the value of gamma d. So generally the graph comes out to be in the shape of a parabola, and this portion and this water content, this is the value of gamma d max, which is the maximum dry density, and the water content here is called the optimum moisture content. So the optimum moisture content gives the value of the gamma d max. So the same graph I have like given over here, and this graph is of the shape of the parabola, which I've told. So as you can see that the weight of the hammer is 2.5 kg. The value of the mold is also given, and 25 blows per layer. All the details which I have already told you is given over here. So what makes this graph important is that the values of the MDD, suppose we have some water content and some value of gamma d to the left of it, then the soil will be high in shear strength. And high shear strength makes it favorable for the use in road courses, embankments, where the need of the shear strength is maximum. And to the right of it is called the wet of OMC. Wet of OMC is the soil where there is no leakage of fluid through it because it is already high in liquid. So generally the cores of the earthen dams are generally made for the wet of the OMC. So the value of the optimum moisture content tells us that the soil is of which quality. For the different types of soil we have different values of OMC, but the graph will be more or less parabolic, above it or below it. Suppose for a different soil it can be like this. For a different soil it can be like this. But it will be in the shape of more or less parabola. So this test is very important. Generally what we consider is when we perform a test on the site, we generally want to take the value to be close to the OMC, but it can't be done in the wholesome scenario. So what we do is we try to achieve a density of 98% to 99% of the generally the lab tested value of the OMC. So this test is very important, and for the soil shear strength and the different parameters associated with it, and it makes this test very important because through this we can design whether the soil is suitable for a certain work or not. So I hope this is my first video and you like the video, and if you have any doubt regarding the standard Proctor's test, you can comment down below and I'll be more than happy to reply you. Thank you.